Let's solve some more problems. Now we have a function which is from natural numbers to natural numbers, defined as f of x is equal to x to the power of x minus 1 to the power of x. What we have to do is show that the function is bijective for all x belonging to natural numbers. Okay. Now let a comma b belong to and let f of a is equal to f of b. Then what happens as per the definition? We get a minus 1 to the power of a is equal to b minus 1 to the power of b. Now here comes the tricky part. When a and b are even, this would be a minus, and this expression will become this term will become plus. Okay, so this will become a minus 1 is equal to b minus 1. 1 cancels and we'll be left with a equal to b. But if they are odd, then what happens? A minus, now this will become minus is equal to b minus 1. So that means this will become a plus 1 and b plus 1. Again 1 cancels, a equal to b. So therefore it is injective. Okay, now let y is equal to x minus 1 to the power of x. Again let's take odd and even. So when x is even, what will happen? This will become x, y is equal to x, this will become plus, so minus 1, and it will become x is equal to y plus 1. Now when x is odd, this would be y is equal to x minus, and this will become minus, so this will be plus 1, and this will become x is equal to y minus 1. Okay, now let's substitute this into the function f of x. So f of y minus y plus 1 is equal to x is y plus 1 minus 1 to the power of y plus 1. Okay, now let's see where y plus 1 is odd or even. Now x is even means what? Y is odd, because we are minus 1. We are doing it minus 1. But now we are adding 1. So it is again even. So this will be even. Now if this is even, this becomes plus 1. So plus 1 minus 1. So which means y. Similarly here y minus 1 is equal to y minus 1 minus 1 to the power of y minus 1. X is odd, so y becomes even, and then it becomes odd again. So which means this becomes plus 1. So these two cancels and it is y. So therefore function is onto or surjective, since both 1-to-1 and onto, therefore bijective. Okay, let's do the second problem. We are given a function natural numbers to natural numbers. F of x is equal to x square plus x plus 1, and we have to show that it is 1-to-1 and on a. So let a comma b belong to the set of natural numbers. Let f of a is equal to f of b. Okay, so a square plus a plus 1 is equal to b square plus b plus 1. 1 cancels out. A square minus b square, a square minus b square plus a minus b equal to 0. This can be written as a plus b times a minus b plus this can be grouped together is equal to 0. Now, a minus b is common. So a plus b plus 1. Now, since a is natural numbers, b is natural numbers, and it is plus 1, that means this will always be greater than 0, which implies that a minus b has to be equal to 0, which means a equal to b. Okay, now we have f of x equal to x square plus x plus 1. Let's say it is equal to y. So now uh, let's uh, uh, do it through perfecting the square. Yes, so let's say x square plus x plus 1 by 4 plus 3 by 4, that 1 by 4 plus 3 by 4 is 1, is equal to y. So this becomes x plus 1 by 4 square, so 1 by 2 square is equal to y minus 3 by. Now let's square root both the sides. So 1 by 2 is equal to square root of y minus 3 by 4, which means x is equal to square root of y minus 3 by 4 minus 1 by. Now, but remember, x is supposed to be, the domain is supposed to be natural numbers, and this does not belong to the set of natural numbers. So therefore, not surjective. Oh, sorry, this is supposed to be into, that is 1-to-1, but not surjective, which is what we have. Okay, let's do the third one. We have a function from a real number to real number defined by f of x is equal to x square plus 8, and we have a function g from real number to real number defined as g of x is equal to 3x cubed plus 1. Now what we have to do is find FOG and GOF, okay, and much more specifically FOG of 2 and GOF of 1. Now FOG of 2 would be equal to f of g of 2, which is equal to f of, now remember g is 3x cubed, so 3x cubed, that is 2 cube plus 1, which is equal to f of 3 times 2 cube is 8, 24 plus 1, which is f of 25. Okay, now f of 25 would be 25 square plus 8, which is 625 plus 8, which is equal to 630. Now GOF of 1 would be G of f of 1, which is going to be x square plus 8. So G of x square, 1 square plus 8, which is G of 9. Now this would be 3 times 9 cube plus 1. 3 times this would be 9 9s 81, 81 9s 729 plus 1. Now multiply these two, we get 2187 plus 1, which is 2188. That is composition of two functions. Now let's do the next one. Now if r positive to r positive, let's say we have a function from positive real numbers to positive real numbers defined as f of x is equal to x square, and g function g again from positive real numbers to positive real numbers defined as f of x equal to square root of x. Okay, the question is find out FOG and GOF and figure out are they equal. Okay, so let x1 belong to positive real numbers. So FOG would be what? FOG of x1 would be f of g of x1, which would be f of g of x1 would be, this is g, this is going to be g. This would be square root of x1. And then f of x would be x squared. So square root of x1 square, which is x1. Now let's find GOF of x1. So now g of f of x1, this will give us, f of x1 will give us x1 square, and then g of x1 square will give us x1. So which implies that FOG is equal to GOF, since f of g of x is equal to g of f of x. Okay, fifth one. Now f of a to a, and we have g of a to a. These are non-standard set. And here this is defined as f of x is equal to x square, and here this is defined as g of x equal to sine pi x by 2. We have to show that g inverse exists and f inverse does not exist. So let's take it one by one. F of x is equal to x square. Okay, so let y belong to a. Let y is equal to x square. So x would be equal to plus or minus square root of y. Since it is plus or minus square root of y, not a bijection, it is not going to be 1 to 1. So therefore it is not invertible. Remember, for it to be invertible, it has to be both 1 to 1 and on. Okay, now let y belong to a. Y is equal to sine pi x by 2. So sine inverse of y would be equal to pi x by 2. Let's take, we want it to be x is equal to, so let's take x is equal to 2 sine inverse of y by pi. Now this is equal to the inverse of g, because if we substitute it back into the function, pi x by 2 is equal to sine pi by 2, and substitute x for this. So 2 by pi sine inverse of y. So pi 2 cancels. So we are left with sine inverse, sine inverse of y, which is equal to y. So therefore G is invertible. Okay, that's it. Bye.